buy from certain stores that are geographically distributed, relevant to our homes. We always hear about where some crime occurred, or where our kids are going to school, or where something's happening. Well, all of that has a location. Now, when we talk about schools and crime and all those things, those are actually demographic problems or issues. Demographics is the study of people and where they live and how those things match with each other. So one of the things that we are interested in at RTI is what defines the community. Because the community is where people are centered, it's where things occur, it's where we are all, it's our core being. A community defines who we are, and we define the community in turn. So we want to know what defines the community, and if you were to draw on a map such a community, how would you define it? Well, we want to be able, once we have an idea of what attributes there are, like where people live, what their incomes are, what their race are, what their ages are, what their household sizes are, or language. We want to know how those define boundaries for where people want to, what are the social boundaries defining people. Of course, we define our own boundaries too. So we have brought our tools and methods. We have investigated these over the past year, and those methods consist of using the graph database, which is Titan. We also use classification algorithms in order to classify where a person might be in a community in terms of those 5 attributes that I just mentioned: race, age, income, size, and language. Currently, we only do 4, but we have that 5th one available. We have actually a lot more attributes than that. We're just only trying 4 at the moment. We also use clustering algorithms to try to identify those community boundaries. So classification and clustering, we're under that big area of machine learning. We'll get into those and what those algorithms are shortly. But I wanted to show you the base data set, which is actually available online, and I can show you guys it afterwards. I will show you a screenshot of what our base data set looks like. It's actually 114 million households that have that currently have 5 different properties. And those data are plotted on a map so that you can see different points. And this is actually, this thing that you see down here is available to the public. You can find your house and see whether or not you actually have a house that's nearby. These don't represent your actual households. This is the population data set that we have. It represents a synthesized household that meets the requirements of your particular census block. So when we say that, when you see these points, note that it's not a real person, a real household that's at that point. These have been aggregated and then synthesized. So graph databases, I will show you real quick because that's central to what we are doing. We are looking at, we got some water real quick. The audio is so loud in here that I have to really project, so I'm not used to projecting that much.
Doing great.
Thank you, thank you. So, graph database, what is it? Think of each person in this room as a node in a graph. The connections between each person as edges in a graph. Twitter and Facebook, those are all big graph networks. Our road network is a graph network. The internet is a graph network. All of those can be represented in a graph database if you had a big enough set of computers. So in the Hadoop ecosystem, you can use one of 3 different types of graph databases. And these are plotted down here. There's one called Apache Giraffe, which uses a lot of Java code. It's also in memory. It's not my most favorite solution. I've looked at it a few times. I haven't really played that much with it. Titan is a great solution. You can represent a road network in Titan. We have Titan on as our graph stack. On top of it is Faunus, which allows you to do batch analytics on graphs, really large graphs. So we have that. Titan is something that if you wanted to represent your local network, you can use that. Does anyone know what this is? Have you seen this picture before? Somebody yell if they've seen this and they know what it is. Don't know what it is. Okay, what, I thought I heard something. No. no.
Is this the augmented job that other package?
It's just one thing, and then, well, it's a combination.
It's a Facebook thing.
Pretty close. It's the internet. So this is the internet. This is actually a visualization of the entire internet. Each of these are supposed to represent pods. We've got computers that are connected to each other, which are these little white things here. And then all of these are cloud internet connections between computers all over the world. It's a visualization. And this is the biggest graph network we possibly have. If we were to represent this in a graph database, we could actually do that because the number of computers is finite. It's going to be like maybe more than 1 billion rows or so, but if we were to represent this, we could certainly do that on a large distributed cluster. This is my personal network on LinkedIn. It's pretty small, so all of you need to go to LinkedIn and help me make that bigger. This is another example of a graph network. You can see the nodes, and you can see the edges between them. Those are connections. In a graph database, these nodes will be represented, and these edges will be represented, and you can label these. And you can also query. So just like you would query a cell or a field for a particular value in a normal relational database, you query who is connected to who. So you can actually entice do a function that allows you to go out. And when you go out, you look at all of the connections that are in the immediate vicinity. Then you can do another out. Then you can go to the next connection. There's all of these different functions that you can use in Titan to do that. And so you can actually trace how everyone's connected to who. And LinkedIn has done this. They obviously know who's connected to who really well. This, I realized no one can see it. I actually presented this slide at RTI the other day. I had a presentation very similar to this one. I presented the slide just for the impact that it would have on people to recognize how many databases there were to handle large data sets or small data sets or any kind of data set. Here we have what we're used to. There's MySQL right here. MySQL is pretty common. You have things like SAP HANA there. These are all relational. And SAP HANA will actually do larger data sets. Postgres, SQL. Out here you have the non-relational zone, which are NoSQL databases. And down here you have the in-memory databases. All of these, this is actually a graph network of databases which are designed some which to analyze graph networks. So this is as of June 2013. So the field is huge. There are so many options to choose from. So how do you know what options to use for your analytics? First of all, you have to pick a data set or a framework that accommodates your data set. So looking at the size, looking at the frequency of your data coming in, choosing whether or not your database will accept those data coming in at a reasonable enough frequency. If you have a lot of users, you might want to choose one or the other. All these are things you can research on your own. I just want to show you the volume of options that there are to handle data nowadays. So with that, I will come back to my use case. We diverged out to graph databases because we're actually using a graph database to model our road networks, which will help us determine distances between these points. So each one of these little points down here are households. And these households have attributes. These attributes are income, size, race, and age. And right now we're plotting one of these attributes, which is household income. And you can see the clustering variables. You can see it even better on the next slide. Which one has the most clustering? According to this one, yes, this one has the most clustering. This one, which one has the least clustering? So I would tell you that this is the race of the head of household. This is the age of the head of household. Over here we have income. Over here we have size. This is New York City, and the New York City area has stark spatial clustering that we can see with our eyes. But how do you make a computer see this on its own? That's what we want to do. We want to automatically have the computer draw a little line around here and say, oh, there's So you can imagine that we have different dimensions here, and the number of dimensions that you would have to do grows as you add more attributes. And so this is a problem that we have faced, and we've been exploring various algorithms to do this. So my thing is, I'm really interested in the processing aspect of this as well. I know that if I can see this, then a computer can see it too. And that's object recognition, the ability to define boundaries around an object. That's actually pretty straightforward to do. It's less straightforward to do in Hadoop. There are tools that will do that for you, but it's something that we haven't investigated just yet that we're looking into. So the approach that we've taken is that we're using the graph database to look at distances between various points over a road network. We want to then use the properties of each of those households to classify those households as being whether they are high income or low household size. So if a single person that's really rich is living there, we want to know that person is so because all the people around them are single and rich as well. So we want to be able to find communities based on that aspect. So I talked about classification and clustering. This is another user tool. How many people have seen this? This chart? Okay, outstanding. So we've got a few. This is just a road map. It's not complete by any stretch of the imagination. It just tells you that if you go down here and you have like labeled data, if your data are labeled, you would use a classification algorithm. If your data are not labeled, you would use a clustering algorithm. I will go over what the algorithms are in a moment, but I just wanted to first let you know what they are. Second, when you would use them. That's the biggest thing. All these algorithms are useful to let you know when to apply them. If you're building a house, you want to know what tools to use to build a house. If you want to solve a problem, you want to know what tools to solve your problem. That's what we'll go into. Well, actually, all these green things here are different types of algorithms. We'll go into that in a little more detail. So I'm going to check the clock real quick because I know we started a little bit on time. So I've got a good 15 minutes outstanding. Classification algorithms. How many people have done K-nearest neighbor? K-nearest neighbor, a lot of K-nearest neighbor. Okay. So in 90 days, how many people have done that? Okay. Some of the same people have. There's logistic regression. I'll just read these. Okay, a lot of people. Great, yeah, because everyone's done logistic regression. How many people have done decision trees? Okay, decision trees, you know people, logistic regression, decision trees are not the same. Random forest. Okay, we've done decision trees and we have not done random forest, look at random forest, because those will be a great help to you to have larger data sets. How many people have done support vector machines? Okay, great. I'll scan neural networks. Okay, look around here, the people who have done neural networks. Raise those hands up higher. Okay, because all these people are going to be people you might want to consult when we do deep learning very shortly. And then how to decide. So, K-nearest neighbor people, you first need to know the size of your training set. Training sets are used in classification algorithms. If you want to classify, you already know your classes, and you want to be able to tell, okay, here I have a household. What properties might that household have? Might it be high income, low size, high age, those types of attributes. You want to classify those as being one of those types. You have to first train your algorithm in order to be able to tell, based upon your training set, what a new point might be like. So, if your size of your training set is small, you can use something like 90 days. If you have a large data set, you might want to try KNN or logistic regression, because those are just faster and they have lower error. When you use KNN, that's always a downside because you have to know the number of clusters that you're going to use. And I'll have, actually what I'm going to do is, because all a nice probabilistic interpretation. So if anything, start with logistic regression. But if you want to try something different, then decision trees are a good choice, but they are also easy to overfit. If you want something that's easy to understand, decision trees are always easy to understand and classify. It's like a dichotomous tree, or if you see like a phylogeny or any kind of tree map, that's what a decision tree is for those who happen to use them. Random forest. I'm a big fan of those, and by the way, all of these that I'm mentioning are actually implemented in Hadoop in some form or another. You can actually perform MapReduce in order to do these. Apache does not do SVMs as of the moment, but they are working on it. So when random forests are implemented, KNN is implemented, recommendation engines are implemented. That's recommendation engines are like I described earlier, the non-use. Logistic regression is definitely implemented as decision trees are. Hierarchical clustering is not, but they have top-down clustering. So those are, I would encourage you guys to look into Apache Hadoop if you're interested in doing classification clustering. When to use SVMs? How many classes can you use an SVM with? Support vector machine. How many classes? Same limit. 2, yes. So if you have more than 2 classes, there's no point using this. I have 4. I have maybe 4 or 5 classes for each of my variables, so I wouldn't use SVMs. But they are very common. They are highly accurate. They are like the method of choice. So if you only have 2 classes, try this. If you have more classes than that, try random forest, or you can also try logistic regression too. Both are fast and scalable. Random forest tend to beat logistic regression in terms of accuracy when you're going large data sets. Lastly, neural networks. I want to show you guys a little photo that's what neural networks have evolved to be, and that would be deep learning. Neural networks, they're really good at capturing complex patterns. They're modeled upon the way the brain works, or at least people try to model it upon the way the brain works, or at least our understanding of how the brain works. So neural networks are our pretty rapid. They are, on average, superior to both naive ways as well as support vector machines. But you can't understand the model. The model's really hard to understand unlike decision trees. So if you need to be able to tell your clients how you classify your data, you don't want to use a neural network. If you want to have a very complex, data set and you want to be able to model it with some high accuracy, you can use a neural network. There are points. I've named it up with algorithms, but if your data are really good and you have lots of it, it's not going to matter what algorithm you use, basically. It might matter a little bit, but better data always trumps better algorithms any day. With a huge data set, if your data are huge, like if you're on the order of terabytes of data, you want something that's going to operate fast. It doesn't really matter which one of these you use. And if your accuracy is paramount, then try a number of these at the same over the period of time. Benchmark them and find out, like cross validation, which one is the best. You can try them all. You can use random forest, for example, to try a whole bunch of different decision trees. Or I think that's the way it works. Random forest is a very powerful method. So. Clustering algorithms. Clustering, these are the ways that these different algorithms run. This one is called DB-scan, and I've actually done a lot of research into this. It's density-based spatial clustering, spatial something applications of noise. I have it on the next slide. DB-scan, this is from the Python scikit-learn page, and it tells you what these algorithms will do with these sorts of data sets. So imagine the synthetic population that I showed you had these clusters. Well, these clusters, I want to be able to identify clusters within clusters. The only one that actually does that is spectral clustering and DB-scan. Spectral clustering, I have a section on the next slide that will show you when you would use that. But I looked at this and I said, well, for my purposes, I want to use one of these two. Actually, I want to use this one because this one here gives a better cluster for this spectral cluster for us. So there is no DB scan is not implemented in the Hadoop, but it is in MapReduce. So this is an outstanding algorithm if you want to identify clusters of locations. And I'll skip this one, and I'll go to this one. When do you use these clustering algorithms? If you want to define your number of clusters beforehand, if you know that you want to separate the room into 3 different groups of people, front, middle, and back, you would then use something like K-means clustering. If you have a direct define that. If you don't want to define it, if you don't know anything about your data, you just want to know, well, which users were participating in which sessions on my website. And you want to be able to optimize your website according to which types of users were using that website at which times, maybe time of day, maybe their ages, maybe according to what products they like to use. You would then say, no, I don't want to define a number of clusters. Then you would use some other algorithm. Well, down here, all I have are scattered objects because I research. But you can use any other type of clustering algorithm that does not require you to look at the number of clusters. If you do want to define a number of clusters, there's 3 that you can choose from, and it all depends on how many clusters you might have. So if you have a few, you use spectral clustering. Spectral clustering looks at a distance matrix between different points and allows you to define clusters based on that. K-means, everybody uses K-means. Every single MapReduce framework that does machine learning uses K-means. And if you have a large number, then you would do something like hierarchical clustering. So those are the different clustering algorithms you might use. Deep learning. I'll wrap up with deep learning. I have a few more slides, but I want to show you guys this most important, awe-inspiring field of big data that I have ever looked at. Basically, deep learning allows you to strengthen up artificial intelligence capabilities. We're actually moving into an age where artificial intelligence is becoming more and more possible. That's because computers are now able to teach themselves how to see and how to interpret language and how to do a number of things that do not require a human programmer to do. So think of a baby that learns sounds at different pitches, and then they learn words, and then they learn sentences, and then they learn how to read later on, and then they sit here at these tables listening to me talk. That is an example of deep learning at its best, but it's done by humans instead of machines. But machines can do this as well, and they do this through layers of neural networks. So layers of neural networks stack on top of each other that communicate with each other. And all these people who raised their hands earlier who worked in neural networks, you guys know something about how deep learning operates. And deep learning, there are different types of algorithms that you can use to do this. Those are restricted multiple machines. There are things like deep learning networks, and there are also autoencoders. And I'll show you an example of how this stuff works on the next slide, but there is a link here to all the information you would ever want to know about deep learning. It's on another meetup site within Chicago, and it posted up a presentation that will go into far more detail in the hour than I ever hoped to say about deep learning. It's way too deep for me. But there are examples. Word2Vec. How many people have heard of Word2Vec from Google? That allows you to find countries written down in text and to identify the capitals of those countries without even teaching a computer to do that. The computer learns these words by itself and learns from the frequency of those words and how they're distributed, that those capitals belong to those countries. You can also teach your computer to read Spanish and learn the Spanish language through deep learning. And finally, Alpha API. You can actually go to this website called Alpha API and look at images that have been recognized. So for example, if you load a bunny rabbit, it'll say, well, this is bunny rabbit with 90% degree of accuracy. It's a cat with like 20% accuracy, or not 10% accuracy, and it's a dog with like no degree of accuracy. So it will actually give you an accuracy level of what it thinks the object is based upon the image that you've given it. And sparse coding, this is what I was interested in when I said image processing with the synthetic population map. When I wanted to find those clusters of households, I was interested in using this kind of method because the way that this works is it breaks up this image into a number of edges or features that are over there called. And these edges have varying degrees of light and dark. What happens with these features is each of these are stitched together to make a representation, a feature representation of a particular item. And then these features then get combined into other features. And if you guys can see this better, you can see how this is down here. This actually gets combined into things like edges of a face, or edges of a table, or edges of something. Those then legs of a chair, or eyes, or noses, or mouths get combined into faces. And then faces get combined into actual pictures. And here you can see that these are a whole bunch of people's faces built up from lines and edges. And this is how I was thinking I could apply this to identify our communities by finding those edges and using this to automatically just find them for me. Haven't gotten that far yet because I'm using graph databases, but this is pretty cool stuff. And back to this. I'll skip these slides because I just wanted to show you guys that Hadoop connects to other things as well. R, SAS, you can run it on .NET, you can run it with Python, and there's SQL Server, which you can run a pattern which allows you to run predictive models from a MicroStrategy, from a SQL Server-based database, and also MongoDB can connect with Hadoop as well. That's another NoSQL database. Now I'll skip these, and I will finally arrive at the end of my presentation. I know everyone's like waiting to chime down the food by now, or maybe it's just me. But I want to give you guys my email address. It's dahlwinters@gmail.com. I also want to leave you with this link, which is the link to my website that has a whole bunch of different resources for learning. It has 3 different ones. One, if you're interested in analytics and science. The other, if you're interested in geospatial analytics. And the third, I keep a code repository of all the different MapReduce code that I find that's really useful. So if you go on there, you can. I have learned all this stuff from Google. I have actually never taken a Coursera course. I learned all this stuff in pretty much last year. So it's been a whirlwind tour for myself, as I hope that it will be for you and your big data explorations. So with that, I'll close and I'll take any questions probably afterwards because it's going to be really loud. Everyone will be back to meetings. So I'll just walk around if you guys have any questions and I'll close now. So thank you very much.
Thank you so very much. All right. So if this is your first, raise your hand if this is your first time here. All right. Everybody who's been here a lot, look around. All right. Be sure and welcome the folks who are new. 2 people lent me an extension cord tonight. One of them was Jamie, heroic food and drink bringing Jamie. Actually lent us an extension cord, and someone else. There you are. Wave. Thank you so very much. Some of you guys might have noticed this slipshod operation going on up here that everybody pitched in and helped with. For about $300, we can get a nano projector that is less than $10 a piece for those of you who are here tonight. If we had a projector where our lives are a lot easier, everybody's lives are a lot easier, consider donating. I know we have students, I know we have folks who are freelancers, do not feel obligated. But if you're saying to yourself, man, wouldn't it be nice if they had a real projector? Come see me, and we will talk about that. Next month is going to be a planning meeting, so we're going to have a meeting around a big round table to talk about what we're going to do for next year. We usually skip December, so December is really, really busy for everybody. So next month is our last meeting. We're going to have it as a round table to talk about what we're going to do for next year. If you have ideas, if you have things you want to do, please watch the meetup group for the November meeting. What have I forgotten? Everybody who normally knows what we're doing.
Having lunches.
I'm sorry? Yes. We missed lunch this month because our lunch organizer and I were both out of town. We're November, so there's a monthly lunch. Again, that's on the Meetup group. If you're hearing about us through LinkedIn, Meetup is the quickest, easiest, fastest way to get to us. So, if you want to donate for a projector, see me. I will definitely post the information that Dahl has so generously offered, both on the website and at Meetup. There will be a lunch. I guess that would be November 4th. That's a Friday, or no, earlier than that. Anyway, there's going to be a lunch soon. I think it's November 1st. And this next month's meeting is a planning meeting. Don't forget to take good care of Jamie. Thank you guys so very much for coming. Let's thank the speaker.